Yeah, hey everyone. I'm Sonny Shi, head of product at Stacklet, based out of Southern California. Yeah, I enjoy all the great amenities. I think Brent was also mentioning. You got the beaches, you got the mountains, you got golf, whatever. It's great to be out and out and about. So just get started with the session today. So today we're going to be talking primarily about sort of a different mode of thinking around managing GPUs, especially from a FinOps point of view with regards to AI. Some of the biggest reasons, and I think it's mostly obvious to everyone in the room, but I think it's still worth mentioning here is that the reason why GPUs are much more of a hot topic is just we're operating at a completely different order of magnitude, right? If you go and you look at how much an EC2 instance costs per hour at the smallest, they're free or they're under $1. They're under like 20 cents an hour to run. Whereas the largest GPU instances, single instances, can cost you, upwards of tens to $50 an hour. So it's multiple orders of magnitude jump that we're talking about here in terms of cost. And the way that we detect and the way that we analyze and understand what is underutilized or what isn't underutilized is also requires a bit more sophistication, right? So default cloud provider metrics that you get out of the box from AWS, Azure, and GCP with things like CPU utilization. Sometimes you chuck an agent on the machine to get memory, you get networking, but GPU utilization is a completely different beast, right? So you may not be CPU bottlenecked when you're running training or inference, and those metrics are just completely useless, basically. You'll have no clue how much VRAM you're using or how much actual GPU node is getting utilized without additional agents or without additional metric sources. So being able to understand how to actually calculate what is underutilized or utilized has a big impact on the actual cost savings that you get. Secondly, so the workloads themselves are also they're bursty, right? They're bursty, they're iterative. It's hard to forecast. When your data scientists or machine learning engineers are trying to understand or build out new models, doing fine tuning or training, that's often a very explorative practice where they're just trying to figure out what works best. And being able to identify that, it's not a steady state operation for those environments. But even in those steady state environments where maybe you're serving inference, that's also a different mode of thinking, right? In terms of you may have a GPU policy here that's trying to identify underutilized instances in your machine learning sandboxes, but you need to tweak that for production. Additionally, there's just new opportunities for waste. So these new waste patterns, there's notebooks, there's endpoints, there's different training job configurations. These are all just completely new concepts for most FinOps practitioners, which means that you need additional tools or you need additional techniques to understand where exactly that waste is coming from. And then finally, talked a lot about the new metrics that you should be looking at, such as VRAM utilization or GPU node utilization. But sometimes those metrics don't tell the full story. So you may be slowed down by a slow data pipeline. So as you're trying to load all the data into your GPU instance into memory, maybe you're bottlenecked just by the IOPS that you have, right? And so you're spending time, you're spending money on a GPU instance, but really what you're spending time on is networking and storage. And so understanding where that is, where those bottlenecks are, is also key to optimizing and making sure that you're not overpaying for GPU spend. Next up, in terms of some four common failure patterns that we see. You're using the wrong GPU tier for the job. Oftentimes, you know, you're not building infrastructure from nothing, right? So you may read a blog post. That blog post may have some Terraform in it that may have a wildly oversized GPU instance, and you're just either prompting to build out your infrastructure and you don't catch that. We're using like a 16x large or 32x large when really, we're really just playing around with a really small model that can maybe live inside a X large or 8x large, right? Oftentimes, having that analysis or not doing that analysis in the first place leads to just really basic one-liner fixes that could save you 2 to 4x just by changing an instance type, for example. But the second is, like I said before, if you're stalled out on a job, you're still paying for that GPU instance, right? If it's for some reason you're troubleshooting your data pipeline for some reason you're not getting the data that you need into the instance, but that GPU instance is still running the entire time. That's really something that you can optimize outside of using something a much more expensive GPU instance type. Thirdly, where do you actually need that VRAM, right? Certainly more VRAM is always going to be more better for a lot of cases, but there is a point of diminishing returns, right? If you're serving models directly on bare metal, or if you're doing training and you know profiling how much VRAM you're using for your training jobs, how much VRAM are you using when you're serving inference, right? Check the pipeline, check to make sure that that's actually where you're constrained at. VRAM itself scales with the instance types, of course, as well. So anytime you go up in size just to get more VRAM, you are effectively doubling your cost. And so that's something to also be aware of. And then finally, you know, basic stuff around disk IO, IOPS, storage. Where is that actual bottleneck? Where are you over provisioning just to try to fix a problem versus solving the root cause? Uh, and then just in general, like what are the metrics that you should actually be looking at? GPU utilization, that's a completely separate metric. It's gathered in a completely separate way, typically. Oftentimes it requires additional agents or software on the instance itself. Your VRAM or memory usage, same idea there, right? It's not going to show up in the default CloudWatch metrics. RAM and VRAM are also completely different metrics as well. So you can't rely on policies that tell you, hey, you're using low RAM to give you any kind of input about how well optimized your VRAM usage is. It's completely separate. Job duration. Are you expecting jobs to finish? How long is your job training on this instance supposed to take? Right? If it's going way longer than expected or it's not returning back, that's something that you can very easily write a policy for to say, hey, anytime that we spin up a GPU instance, we only expect that instance to run for a configured amount of time, right? Build in that default behavior that we were talking about before, just to make sure that you don't have any very simple but easy to fix mistakes. Custom metrics as well, right? So if you're looking at unit economics, right? How much is your throughput per dollar? How much value do you get out this instance, right? You can collect those metrics and help to understand what's your actual ROI on running any of these instances or predicted ROI. Idle time and data and IO constraints, making sure that I think to Lindbergh's point that you just turn off the lights after you're done, right? If you're not getting any value, but you're paying, hundreds or thousands of dollars on hardware that you don't need, it's one of the easiest things to get right. It's just, hey, after some amount of time, if we detect low GPU utilization, that we just stop the instance. You don't have to terminate or delete it, but stop it. That's recoverable, but you're not paying for that instance in full at that time. And then most GPU waste doesn't actually come from the training. It comes from all the other things, whether it's, forgetting to turn it off, it's not right sizing, it's not using spot instances. A lot of training jobs, especially from the sort of managed training services like SageMaker, and AWS, it's a one-liner to use or not use spot instances, right? To enable checkpoints so that you can recover from that. It's not, fixing upstream problems before scaling GPUs. It's not fixing your data pipeline. It's not fixing the way that you're loading that data into S3 from S3 into your instances. Or it's all the other things that people forget that they had to build, right? Models that you're serving that you've trained. It's endpoints, it's checkpoints. There's a whole plethora of new services and new things that you can do with all these AI models, and everyone's using everything, which means that it's hard to keep track of it all. And in terms of oops, what policies you can put into place today, right? Talked a lot about gathering the right metrics, finding and detecting and suspending those underutilized GPUs, so idle detection and right sizing, terminating any of these stalled jobs. You can very easily write a policy that goes and look for SageMaker jobs that are running for longer than, 48 hours or 24 hours, and just say, hey, just want to poke you on the shoulder here. Do you actually need this job to keep running? Enforcing right sizing on accelerators, requiring spot instances, again, like it's a one-liner in the job definition to say, hey, use Spot, right? If it's purely exploratory, if it's something that is not super critical, but um, still you still need a GPU attached to it, go and look into if Spot works for you, if you can set up checkpoints, um, and that I think could be a huge boon to making sure that you're more efficient, even when you're exploring some of these high compute use cases. And then finally, what does good look like? So provision with guardrails. I think Brent mentioned earlier that they have a process, right? They have policies in place. It's both a technology policy to enable or approve or deny GPU utilization, but it's also a people process, right? Making sure that your users are aware that, hey, when I go and provision an instance, that there are just things that I shouldn't be doing, right? Or that I can do, but I need to go talk to, the infrastructure team to make sure I have a valid use case. Develop with policies, right? So job timeouts, VRAM thresholds, idle limits, make it active from day one, or like other people have said before, the best time to start was yesterday. The second best time is right now. So put in place that policy to make sure that you have those, your developers are in the loop, that they know what's expected of them when they use the cloud, and then monitor what actually matters, right? It's not about CPU utilization anymore. It's not about RAM. It's not about network. Uh, these are completely different metrics that require completely different systems to collect those metrics and understand and analyze those metrics. And then finally, right sizing. It's not a quarterly or annual process. This is something that you can just do autonomously in the background. Once you have those metrics to understand, hey, we noticed that this instance is running at 20% VRAM usage for the last 2 weeks. Is that something that we can right size, right? To put that into place, to have it automatically do that right sizing with you, making sure that your developers are in the loop, that they know what's going on, but that you can make the best decision for them automatically, so they don't have to. GPUs, they're not going to wait for your next cost review. They're not going to wait for your next pull up to understand where they could save money. They're gonna consume what they consume, right? And so putting in those autonomous guardrails, those automated guardrails, just helps you have peace of mind so that you can focus on more higher level strategic things about what are your strategic goals around AI and R&D, while still remaining efficient. So I think that's my time there. Thanks everyone for listening, and I will hand it back over to Umair.